So when we talk about regression, basically it is try to test whether there's a significant relationship between two variables. And as I said about the quality of the variables, we have to make sure that the y and x, y dependent variable, x independent variables, they must normally should be ordinal interval or ratio variables. Sometimes they can be nominal, but only binary variable accepted for you can put into the equation. So basically, a simple linear regression is used to identify the relationship between y and x. Here, x is the independent variables, and y is the dependent variables. Okay, and how can the SPSS program can help us to identify y, x, a, and b? Okay, here comes the practice. I use one of the students' program to give you some idea. So let's say this. Let's look about this one. I noticed that there are two variables here, average income and average cost. So this is related to the average monthly income and average monthly spending. So if we look at here, so look, this is apparently ordinal, right? So starting from 9, 8 is higher and higher and higher, right? So there's a ranking. And let's examine the number here. There's a ranking here. Start high, the highest is 8, the 9, and the lowest is 1. So we have a hypothesis here. Is there a relations between can we use in another way? Can we use this one? Can we use average income, monthly average income, to predict average monthly spending? Can we do that? So is there a close relationship between these two? So to solve to provide answers to our questions, here because these are both of them are ordinal variable at least, so they are qualified for linear regression analysis. So we can use analyze. So we click linear regression. Regression is here. So this is linear regression. Sometimes you will love to use some other forms. You can just try to explore by yourself. But the most simple form of linear regression analysis is linear regression. It only accepts two. So let's see this one. We have dependent variables and independent variables, right? So let's see which one is independent variables. In this case, of course, the money you earned and the money you spent. So normally, income should come first before the money you can spend, right? So it is logically to put average this one into independent variables. So it's here. And dependent variable is, you can only put one, so it's fine. So let's find out the average cost. So this is something we want, right? So look here, we put the average income, monthly income as X, and the average monthly spending as the Y. So Y and X we just put over there. So we can see what kind of statistics we would like to have. So basically, these are default values. So you just put over there, that is good enough. For the first try, you just keep this. That is good. And let's see the other one. Can we plot? Yes, we could plot. We can plot these two, whether this one, and normal probability plot, and so on. So you will provide you a vivid visual image about the relation between these two. So we continue. And you can try to find out other options, but basically this is good enough. So when we have this, then we can click OK. So let's see what will be the OK mean for us. Okay, so here is the output. starting from this one. So let's see. We say there's a plot, right? So look here. This is the so-called scatter plot. 分散图表. Scatter plot is the place to plot x and y. This is x, and this is y. So you can see the x happen here and the y is happening here. So every point in here has two values, 1 and 1. So this is what we call xy plot, right? So if you look at this one, this is a regression line. 回归线. So this regression line indicates a formula that we can use this to predict this. Okay, but other than this, let's move down a little bit here. This is normally what we have from the table. Because this one is too small, let me try to see if we can have a larger picture for this one. Okay, so let me. Okay, so I only keep one here. Okay, so can you see anything over here? Very difficult. But let me export it. I try to export to an Excel file, so that would be easier for me to explain the meaning of this number. Okay, so just try to export here. Let me see what can I have. Or and file name, a test for linear. Okay, so I can just click OK, and I need to, but what's a correct file name given? Let me try to do it. Okay, later, let me just use this one, and let me see if I can. Oh, yeah, I can. Let me just copy it into the Excel file. I hope that we can copy it. Okay, much better. Okay, so that would be much easier for us to explain the meaning of the different numbers here. Okay, so just take this out. Really is to occupy too much space here. Okay, so here is what we need for illustration purpose. So let's take a look here. Normally, when you output this one, there are a lot of tables shown in this output. For example, it will say this one. This one is this one, right? So you can see this one is here. So we have the average, we have this number, and we have the model here, R squared, and adjusted R squared, and the standard deviation, and the standard deviation of the error. And this is a ANOVA test. This is ANOVA. This one to here, right? So we can see that there are a lot of numbers here. And here is something we'll look at, but this one is mostly important part. We're going to use it. Okay, so now, what do this number means? What do this number means to us? I want you to open your reference menu. Open your reference menu and move to page, let's see, page 117. So 117 provides us a very simple writing template for linear regression. This is the template. Did you see it? And I also post a link for you to, there are many different forms, different ways to report a linear regression. But there are some requirements. And the requirements, some of the requirements are here. Let me show you. You can click, just like this one, you can click the link. And get into, you will, if you click, you will find out this document, this website. So you can see what is the format to report. So basically, we need to report the information here. Okay, so this is something we need to report. This is one form. And this is the template, the model, and here is the example. Here is the example that we can use the formula, the template above to write out something like this. But this one is one way of reporting. And there's another way. You can use this one to report. But basically, both formats consist of the same information. They all have the same information. So now let me try to give you an idea how to report for this case. Let's take a look. Some students, just like you, if you have no idea about how to report the linear regression correctly, normally you will just copy. And you will copy this. You will only copy this and paste on your paper. And you will just paste them on the paper. And it looks so nice over here, right? But I will tell you, this is totally wrong. This is a wrong approach because the output here only provides you the necessary information which you need to take it out and put into your writing. So let's compare what kind of information we need to put in. And here are very important, I would like you to pay attention to. So let's move up here and make this a little bit here. So after we use analyze and regression and use linear regression, put our independent variable and dependent variables and make sure the statistics and the plots are set. Then you click OK. Once you click OK, then you will have some output just like this. This is the output. And now I copy the output over here for the convenience of illustration. But basically, you have to look at this first, of course, right? So now let me take this a little bit down. And I will pop up the writing sample for you to report what we should need to. Okay, so when we try to identify the relationship between independent variables and independent variables, actually we try to understand whether there is a significant relationship between x and y, right? So let's see this one. Let me move this to here first, okay? So this one is a very, very mechanic way of writing. So basically, it is used to report several important ingredients. The first one is to report what kind of test. The test was used to see this one significantly predicted this one. So basically, this is the X, and this is the Y examination score. So first one to report the test statistical procedure to be used. And the second one is to identify the regression model. Was exam score equal to 7.1617 plus 5.2503 times hours studied. And the overall regression was statistically significant because there's a number here. And it was found that our studied significantly predicted exam variables. And the beta value is 5.2503, and the p-value is less than 0.000. Okay, so here is the template. Then how can we use it to write it out? Now I want you to look at the different comparison between this and here. Okay, let me take this away. Okay, and I will take away some of the columns so I can have a better view of the output. Okay, so let's take a look at this one. Basically, the number we need come out from these tables. 1, 2, and 3. So let me compare the notes to you. So I have a writing sample here. Get it smaller. My writing sample to report the result is here. Okay, so let me compare the number for you. So simple linear regression was used to test if average monthly income significantly predict average monthly spending. So I report the test and the test target. And then I report the regression model. The fitted regression model was average monthly income spending. Now comes out the idea. This one, beta value. 0.11 is here. Okay, be careful with this one. And plus 4.411 is here. And times average monthly income. So this one, 0.411 times average income. So basically this is 0.711 plus 0.411 times average monthly income. So this report the establishment of the formula, which means, let me give you the example. If your average income is 20,000, so could you tell me what would be the, if your average income is 20,000 and no, I'm sorry, your average income is on category 8, then what would be the category for your monthly spending? Can you do the calculation? We know, let me write this for you. So if your average monthly income is 8, because there are 9 different values, 1 to 8, 1 to 9, right? So now you have 8. Then what is the predicted value of your, let's say, monthly average monthly spending? Okay, now please, anyone, you have to answer me. What is the predicted value of your average monthly income spending? Average monthly spending. Come on, you can use the calculator here. And follow this formula. Come on, everyone has to provide your answer. But we have only 11 students here. So strange. 12. Hurry up, and I will use this as a roll call too. Okay, hurry up. Use the formula here to calculate the number, average monthly spending. And remember, this also serves as your roll call. I want to make sure that you're here instead of just going somewhere. 不懂，不会。My goodness，哎呀，我也不尴尬，对不起啊。Okay, now since we have finished the first round of roll call, then let me explain to you. So we suppose that the average monthly income is 8. Then the predicted average monthly spending is 3.999. Let us go back to the original, this one. So look here. This is average income, right? So the range that varies from 1 to 9. So now the value is 8. So one of the respondents chose 8. So what would be the predictive value for him or for her to choose the average monthly spending from here to here? The answer is here, around 4, right? So this is the purpose for the regression analysis. We try to use one variable to predict another variable, the variable. So over here we have, if we know that someone has chosen this one 7, and then what would be the value for him to choose this one? Very simple. Is that right? So basically, we are using linear regression to predict this. So let's have another try. If so, can you answer this question? So let's assume if he chose 5 for his average monthly income, then what is the predicted choice in his average monthly spending? Again, this formula can be helpful. Okay, now try your best. 好，算好了吗？5.61 is way too much. Oh, yes, oh. Yes. Okay, yeah, you're right. So let's look at this one. So basically, this one is used to create some kind of predictive formula. So now average monthly spending is equal to 0.711 plus 0.411 times 5 equals to 2.7666. But according to a choice we have from 1, 2, 3, 4 to 9, it's very highly possible that he has chosen 3. So this is a predicted value. Okay, so that is the purpose of the linear regression. Okay, so far. So let's see. We have used this formula and to write out. So this is what we call the predicted fitted regression model. This is the model here. Okay, but we want to know whether this is significant. Yes, indeed, we can have a very simple formula based on these two numbers. This is beta, and this is the independent variable. So the next step is to make sure this regression, this is the regression line formula, this one. This one is the regression formula. So the overall regression was statistically significant. So we continue to justify whether this is useful to say, hey, we can use this one to predict the average monthly spending. We found out that it is statistically significant. This means, yes, indeed, we can use this one. But how about if this is not significant? If this is not significant, and then we have another way to show. Let us show this. So where are the numbers here? The one is R squared. Let me show you. R squared. R squared refers to this one. R 平方. What does this mean? This means that the 33.8% of the value for this value can be predicted by these independent variables. So basically, this means this. 33% of the average monthly spending can be predicted by the average monthly income. The correctness is this one. Okay? And what is the probability of this one? Then did you see another one here? So we see the number is here. R squared equal to 0.338. And then the variance, F score. F score is about here. F score, we have the 1 and 26. Oh, I'm wrong for this. It's not 28, it's 26. 26 here, 1 and 26 here, right? Okay, so Let's compare the node. This is the degree of freedom, and this is regression, residual, and 26. 1 and 26. So the F score is 13.276. And the probability of this one is P equal to here. So look here. To write out the statement here, we need to have this and this. This come out from here and here, here. That's it. Okay. So this tell you, what does this tell you? This tell us about one thing. The regression formula we have produced here was statistically significant because look at the evidence. The R square is 33.8%, and the variance based on the degree of freedom 1 and 26, the F score is 13.276. The probability of they have no relation is only 1 out of 1,000. So it's much lower than 0.05, right? So this one is significant. You get it? So now let's look at throughout all the tables that we have produced in our output. Actually, there are only several numbers we need to care for. One is this one. This one, this number is the constant, and this number is the beta value for average income per month. So look here, we only need to take these numbers, and all else are not so relevant. Okay, so now we use the statement to support this is a significant formula. And here comes the conclusion. So it was found that average monthly income significantly predicted average monthly spending. And this is average monthly spending. And the beta value is 0.411, and the probability for this one is this one. This is this. Because look here. This one refers to this one. Okay. So this is the way for our report. When you want to report your regression analysis, you need to include this component. Okay, so now I'm going to give you 5 minutes to go over the process by yourself, and back to you in 5 minutes. So I shall continue. And now I'm going to tell you some of the secrets of the table, the output here. So let's take a look about the number. There are so many numbers out there, right? So we have an R score. Normally we call R as a Pearson coefficient, Pearson 系数. So Pearson R and the R square, what does that mean? R square, could you use your calculator to do the calculation? And that is, let me calculate that for you. 0.5.1 times 0.58. Okay, did you see the number here? So we call R square actually is the square of 0.581. So once you do this, then you see that 0.58 times 2 equal to 0.338. This is the number. Actually, it is. So that's why we call R square. Okay, so they are related. And now let's look at the regression and procedure. So the number here and this one divided by 1 is 2.173. And this number, sum of the square, is the variance here is 4.258 divided by degree of freedom 26 is this number. So this one divided by 26 is this. Then what is how can we produce the 13.276? Basically, it is the number 2.17 divided by 0.164 is equal to here. So they are all related. Okay. Okay, now, any questions so far? So if not, let's move down to another way of writing the report. Have you noticed that this one is very not so natural? It's just like a robot. This one is very similar to a robot writing, right? Very strange. Yes, indeed. This one report the purpose of your test. And this one, hey, this is the test procedure, and this is my target report. And this is the identified formula. And is that significant or not? Yes, it is significant. And so here comes my conclusion. So this is very mechanical. Can we use a more human style of writing? Yes, indeed, we have. There's another way to write it out, just like something like this. This is the way of the writing, and that's a simple, so still this is to report. This is a report the process to our purpose, right? And we have found out the significant regression was found with R squared, this one. We have found out this one. And so here is the regression equation. Participants' predicted weight is equal to this one. So you see this is the formula. And when height is measured in inches. So here is a conclusion. Same, but they just include in one passage. So let's use the same output and same writing style to identify the components we need to write here. So first, simple linear regression was calculated to predict. Again, we have this predict average monthly spending based on average monthly income. So this is X and this is Y, right? Okay, fine. So we've identified a significant regression equation was found. Why it is significant? See, the F value, oh, again, I put it, simply copied, so I was wrong. It's 26, okay? So now was found, significant regression equation was found because look at this, the F value is equal to when the degree of freedom 1 for the procedure, for the regression, and 26 for the procedures is equal to 13 point, this one, and the p-value is this one. And we have an R square of this one, okay? So for this one is to verify the regression equation is significant, okay? And not yet to tell you what is the regression. Then here comes the regression. Average monthly spending's predicted weight is equal to 0.11711 plus this one. So look here, 711 is here, right? And this is here. So average monthly spending increased for each monthly income in this. So this just repeat here. So look here, this one is still about the same information. following by starting from here and to produce here. Okay, I'll give you 3 minutes to see the correlation between the number shown here, written here, and the number output here. Okay, 3 minutes for you. So if there's no relationship, then you need only to provide the information such as this, just like this. Okay, any question?